Today we're going to take a look at the first two equations in the big three. So what I have displayed for you right now is your equation sheet. Equation 1 is right here, equation 2 is here, and equation 3 is here. This fourth equation is not a part of the big three, but it is needed to explain something about x and x naught. It just simply says that the displacement, known as delta x, is x final minus x initial. So I'm going to start with defining some of these variables for you. There are a total of 6 that you'll see: x naught, x, v naught, v, a, and t. X naught is known as the initial position, and the initial position is given in the unit of meters, abbreviated with an m. X is the final position, but ultimately nobody really cares about the initial and final positions. More often than not, it is actually better to look at delta x. So the second equation here, I'm going to actually modify it by simply subtracting x naught from both sides. If I subtract x naught from both sides, it becomes x minus x naught equals v naught t plus 1/2 at squared. Or delta x is v naught t plus 1/2 at squared. This is the way I'm going to be referencing the second equation throughout today. Your other four variables, v naught and v, so just like initial and final positions, v naught is initial and v is final, except instead of position, it is a velocity. The units for this are meters per second. Next up, a is acceleration, which I'll define for you in a moment. The units for acceleration are meters per second squared. That is meters per second per second. And t stands for time, which is in seconds. So I told you I would define acceleration for you. So acceleration causes changes in velocity. There's three ways it can do it. You can cause an object to speed up, cause an object to slow down, and it can cause an object to change direction. Sometimes it can speed up and change direction, slow down and change direction. You obviously can't speed up and slow down simultaneously. It's also worth noting that there's no such thing as deceleration. That would just be acceleration that opposes the velocity. Now, looking at these two equations, the number one question I get asked is, how do I know which one to use? And the answer to that is, I don't know, which is a very unsatisfying answer. I agree. But truthfully, I don't know. What I do is I identify what variables I know, and then I take a look at the equations. You're given two to work with today, so I'm always going to start by looking at the shorter one up top. And if it leaves me in a situation where there's only one unknown variable, I'm going to use it to find out what is the value of that unknown variable. If I have two or more unknown variables, I'm going to skip it and move on to the second equation. So this first example says a car accelerates from rest. So from rest is a key term that tells me the initial velocity was 0. It reaches a speed of 35, so v final is 35, and a total of 6 seconds, so time is 6 seconds. Looking at the first equation, I know v, I know v naught, and I know time. There's only one thing I don't know, and that's acceleration. So the first equation is going to work perfectly when I want to figure out what is the car's acceleration. 35 is 0 plus a times 6. So that's 35 equals 6a. You divide out the 6. 35 divided by 6 will yield 5.83. So 5.83 meters per second squared. Number 2, a car is traveling 22 meters per second, so that's v initial. It slows down to 15, that's v final, and it takes 2 seconds, that's time. Find the acceleration. Again, I know v, v initial, and time. That will allow me to solve acceleration. V is v naught plus at. So 15 equals 22 plus a times 2. I'll subtract the 22 both sides first. Moving over here, that will give me a negative 7 equals 2a. Divide out the 2. The acceleration is negative 3.5. The acceleration should be negative because you had positive velocities and you slowed down. Moving on to number 3. A car engine can apply an acceleration of 5.55. How long does it take a car to reach a speed of 20? So how long would it take to reach the speed? Your v initial will be 0, assuming we're starting from rest. I have v, v initial, acceleration. I can now find time. V is v initial plus at. So 20 is 0 plus 5.55 t. It now becomes a matter of taking 20 and dividing it by 5.55. And the time is 3.60 seconds. Moving on to 4. A car traveling at 5 meters per second accelerates with an acceleration of 4.20 meters per second squared, and does it for 3 seconds. Determine the distance the car traveled. So the first equation, again, I got v naught, a, and t. So I could figure out what is the final velocity, but that's not what the question is asking me. It's asking me for the distance traveled. Well, if I'm traveling in a straight line, that means my distance is my displacement. So I'm going to go ahead and use the second equation. Not that there's anything wrong with the first equation, but the first equation doesn't tell me what I actually want to know, and that is delta x. So as I talked about earlier, I'm going to use delta x as v naught t plus 1/2 at squared. So delta x will be 5 times 3 plus 1/2 times 4.20 times 3 squared. This is 18.9. And the conclusion is it traveled 33.9 meters. Our last question. Car is traveling 28 meters per second. That's v initial. Driver hits the brakes. Magnitude of the acceleration is 12.5. Now, I want to bring up the point that I'm hitting the brakes with a positive velocity. Magnitudes are always given as positive, but I'm going to want to use a negative 12.5 for the acceleration because the acceleration is removing the velocity. The time is 2 seconds, and the question is how far did the car travel? Just like last time, I could figure out what the final velocity is, but that doesn't actually answer the question. So I'm going to go to the second equation. If any time I'm dealing with distance, the first equation won't help me because it doesn't deal with distance. Delta x is 28 times 2 plus 1/2 negative 12.5 times 2 squared. So delta x will be 56. 2 squared is 4, multiplied by 1/2, that becomes 2. 2 by 12.5 is negative 25. 56 minus 25 will yield 31 meters. Good luck on your web assignment.